So in this section, we're going to be talking about early Earth and the origin of life. And so we want to look at where life first came from. And we talked about properties of life. One of the cell doctrine or cell theory was cells come from pre-existing cells. So the question really is, where did that first cell come from? So we want to take a look at some of the evidence out there. Now, here we go. We have the history of life. We're going to talk about some of these topics about changes, extinctions, adaptive radiation, support from the fossil record, all those things we'll talk about. And then here we can see the common ancestor. But the question is always going to be, where did that common ancestor come from? And really, there are, I suppose, three ways that it could happen. One is a higher being, a God, Allah, or the giant pickle. Again, I don't know what you believe in. But as we talked about the first week of class, that is a question of faith and not a science. It's not testable. So it's not really a question that maybe science can answer. The second one is outer space. I like that only because what we do is we push that question out into space. And maybe that's actually true. Maybe it did come in on an asteroid or a meteorite or something. So we have no evidence of that per se, but again, a possibility. But then the question still remains: where did that come from before? And then there is the chemical origin of life, which suggests that it actually happened on this planet. And so that is the one that we can actually test and look at. So that is what we're going to do. And so there have been studies done trying to explain how life could come up on this planet. The one I want you to know here in the 20s is by Operin and Haldane, two chemists. And what they discovered is that the Earth today is quite a bit different than the Earth back then. So there was very little oxygen. They were looking at rock samples and realized that in those samples, there isn't a lot of trapped oxygen. The Earth itself would not have the ozone layer that we have today. And that layer of O3 actually allows us to survive on the planet. It actually filters out most of the UV radiation that causes mutations and things like that in us. And then there's probably lots of storms and lightning and things like that. So these are conditions that they believed the early Earth had. Now, the one thing I would like to say about oxygen before we move on is oxygen is very corrosive. And it actually, although we need it for life, high levels of oxygen can actually be non-beneficial. It can actually cause issues. So the fact that there was very little oxygen at the time might have actually helped with the first type of life. And so early on, where did life come from? The idea was a spontaneous generation, that life just showed up. Back in history, when they didn't understand it, they would see growths like on cheese, you see mold. And they thought it just spontaneously showed up. Moss would show up in grain. Again, they just thought they showed up. They didn't realize that there were eggs in it, or for the mold, that there's spores in the air that they couldn't see. And dogs getting worms, those kinds of things, they just thought they spontaneously showed up. Now, reality is that is not true. We know that's not true. And in this picture, this is an artist rendition of Stanley Miller, who came up with the idea of biogenesis. And he did this very famous experiment with Harold Urey, which again is another chemist. But what he came up with is, if you see in the bottom picture there, is he took a broth and sterilized it by heating it up. And then when you just leave it out, all of a sudden microorganisms show up. And then, is that spontaneous generation? Or are there really, things in the air? Then what he did is he did the same thing, but he had it in a sealed glass container, and no microorganisms form. So there was no way for it to get in. But the argument could be there's no air in there or no new air in there, and maybe that's the deal. So he actually designed this flask with this long neck and sterilized it, and found out that the microorganisms could not get into the neck. And so as long as they heated it up, it would all stay clean until they actually physically broke that neck on the flask. And when they did that, then it would become contaminated. So he really was the kind of the proof that of biogenesis, that it actually is coming from something. It's not just spontaneous generation. All right, so in the experiments in 1953, Miller and Urey started mixing gases, methane, ammonia, hydrogen, water, and heated it up. That was supposed to represent lightning by adding heat and energy to it. The little electric shock for the lightning, and the heat for the Earth, a little bit warmer than it is today. And they were able to produce some of the amino acids. Since then, further experiments have actually produced all 20 amino acids, carbohydrates, ATP, purines, pyrimidines, and lipids. So those are all the building blocks of life. One of the things that happened is Miller and Urey did not make all 20 amino acids, and it actually, the process they were using took a very long time to get what they produced. So they ended up stopping. But reality is, what happened is somebody found their equipment. They actually found their initial studies and finished it with better techniques, and actually did find that they can produce all 20 of those amino acids. And so anyway, the idea behind this was that, and this was done just in 2008. So they've gotten everything they need at this point to make life. Now, I want to make sure you understand, we haven't made life. That is not what we've done. We've just made the building blocks. All right, now how do you put those building blocks together to make larger molecules? And there's a couple of different theories out there on how you can make some organic polymers. One is by Sidney Fox. Warm water with pre-molecule splashing on hot clay. The clay was actually acting as a catalyst and allowing for larger molecules to kind of float back in. The other theory is that the sulfur vents, the overheated water mixed with minerals and gases underneath the water with pressure, and that put it together. Now, both of these will actually get you slightly larger molecules. So there is a way of doing that. So now not only are we getting the building blocks, but we're also getting some larger organic molecules. Again, we have not made life yet. All right, and then there's another idea about these protocells. And what we're looking at here is we have these pretty much lipids, these big fat vesicles. And what these things are just that. And what happens with this, and the concept is that some of the properties of life, one is reproduction and one is some kind of metabolism. And what happens is these protocells do have the ability to replicate. They will break into smaller balls, and kind of, you can even produce some vesicles. And then they can also break down glucose phosphate into maltose. So there are some very simple metabolistic processes that they can do. Again, we're not saying it's life. We're just saying that there are these molecules that can do a couple of those properties. And then the last thing would be RNA. And today, we think of the genetic information is DNA, and it is in most species. You know, viruses do have some RNA strands, but DNA is the genetic material for life. But it's theorized that RNA might have been the origin of life molecule, because RNA is single-stranded versus double-stranded. RNA is actually highly susceptible to mutations. RNA can actually act as an enzyme. We call those ribozymes from before. So it would be easier if RNA was the original gene, because you can make copies pretty easily, and because, again, shorter in length. The theory behind that is DNA, being the molecule of genetics for today, is it's more stable. But back then, when things are changing, the environment is changing, and you're trying to come into existence, I don't know how else to say it, RNA makes more sense. Again, with all this information I just gave you, we have not created life in a laboratory from just molecules. If we had, that would be, you would hear it all over the news, and there would be a Nobel Prize. All right, so that's it for the origin.